All right, here are some polynomial review questions. Just make sure we know how to do all these types of things before the final exam. Let's get started. We've got our first one here. We've got negative 3a squared times a cubed plus 5a minus 2. This bracket here shows us that we need to distribute this to all of the inside bits. So let's start. Negative 3a squared times a cubed is negative 3. There's no coefficient, or maybe there's a 1. Negative 3 times 1 is the same. And a squared times a cubed is a to the 2 plus 3, if you remember your exponent rules, which is a to the 5th. Next, negative 3a squared, times 5a is negative 3 times 5 is negative 15. A squared times a is a to the 2 plus, how many a's are here? 1. So 2 plus 1 is 3. And negative 3a times negative 2. Negative 3 times negative 2 is positive 6. And a squared times, there's no a's to play with there, so we just leave it as 6a squared. So this would be the expansion, simplification, or just doing the thing that's expected of you for this type of question. Just distribute what's inside. There are no like terms, nothing else to do after this point. Let's try another. Here we've got negative 7a squared b cubed squared. If you're squaring something, you can think of it two ways. One of them is that you're doing this, which is fine. You do negative 7 times negative 7 is 49. A squared times a squared is a to the 2 plus 2, which is a to the 4. And b cubed times b cubed is b to the 3 plus 3, which is b to the 6. We could do like that. Or we could think about it another way. So we'll get the same answer. This is going to be our answer. Or we could think about it as taking this 2 and applying it to everything on the inside, which generally is a little bit faster, but that's okay. So negative 2 here is negative 7 squared. So sorry, not negative 2. The 2 exponent here applied to negative 7 is negative 7 squared, which is 49. Remember, negative 7 times negative 7 is positive 49. The the 2 exponent, I keep calling it negative 2 for some reason, for a squared is a to the 2 times 2. 2 times 2 is 4. And we've also got here this 2 and that 3. B cubed squared is b to the 3 times 2, which is b to the 6. Same answer, but just two ways to look at it. Both of them work. Whichever one is most familiar to you at this point, you should probably stick with. Let's do another. We have here root 64 plus 3 cubed minus root 144 plus 5 squared. This is just an order of operations question, but it's got exponents in it and roots in it. So root 64, you take the square root of 64, that's asking what times itself is 64. You may have memorized this. It's 8. If you haven't memorized it, laundry's done. If you haven't memorized it, then you can use the square root button on your calculator. 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Root 144. 144 is 12 times 12, so the square root of 144 is 12. And 5 squared is 5 times 5, which is 25. Now all we do is we take these individual bits and add and subtract them. 8 plus 27 is 35, minus 12 is 23, plus 25 gets us our total of 48. Let's do 3 more. Here we've got a division one, and we've got 3 terms on top, 1, 2, 3 terms on top, all being divided by the same denominator. That means we need to be careful that we don't accidentally cancel something we shouldn't. I like to rewrite these as 3 separate terms. So my first one over 3mn. My second one over still the same denominator. And my third one over the same denominator. This denominator here is here, there, and there. It's just a reminder to myself that it really is dividing this, this, and that I can't, can't just ignore that. I can't forget it. So in the first term, come back to it, we've got 3m cubed n squared over 3mn. 3 over 3 cancels out, that's 1. Anything divided by itself is 1. M cubed over m is m to the 3 minus 1, or we can say m squared. N squared over n is n to the 2 minus 1. 2 minus 1 is just 1, or we could just write n. That's this first term. Our second term, I'm not going to use blue. I don't think my eyes like that right now. I'll just use a different color. We have 9 over 3, 9 and 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 3 over 1 is 3. M divided by m cancels out. N divided by n cancels out. So this term here just simplifies to 3, negative 3. And in our last term here, 15m to the fourth, n to the fourth over 3mn. 15 over 3, 15 by 3 is 5, 3 by 3 is 1, this is 5. M to the fourth over m is m to the 4 minus 1, which is m cubed. And, I'll just leave that. N to the 4 over n is the exact same, n to the 4 minus 1, which is n cubed as well. These are our three terms. They are not like terms. They don't share the same exponents with the same letters. I'm going to rewrite them just from the greatest order down. So the one with the most number of variables with exponents, next number of exponents, and the last one will just be the constant. These are the three terms. All I've done is rearrange them by descending order. Let's do two more. We got negative p squared times negative q squared r cubed p to the fourth times 17r. Looks kind of messy, but let's just do it by pairs. Let's take these two, multiply them together. Remember, if there's no addition or subtraction in there, that's a multiplication. And then later we'll multiply by this one. We'll just do it in 2 steps. So negative p squared times negative q squared r cubed p to the fourth. This is one term. Negative times negative is going to be positive. This q has nothing to match with. There's still a q squared there. This r has nothing to match with. Over here, there's still just r cubed. And the p's do match. This is p to the 2 plus 4, which we'll call 6. That's what I like to call 2 plus 4. And we still have 17r off to the side that we need to multiply. So step 2 is doing that. Step 2 is to do the number times the number. What number is here? If it's invisible, it's a 1. 17 times 1 is just 17. Q squared has nothing to play with. R cubed has an r. That's r to the 3, and there's another r over there. So 3 plus 1 is 4. And lastly, p to the 6. There's no p's over here, so that doesn't change at all. So our product, once we've done both steps there, is 17q squared r to the 4th, p to the 6th. Last here, we have another polynomial thing where we're putting some terms together. 8x squared minus 3x minus negative 3x squared plus 3x. This is going to be the thing. Pay attention to negative signs in front of brackets. They'll get you. I'm going to first, well, this first bracket is useless, right? There's nothing going on that I can do. These are unlike terms. I can't combine them. I'm just going to write them out. Next, I'm going to take a look at this negative sign and I'll distribute it to everything inside the bracket so I can stop worrying about it. It bothers me that it's there. I would like to make it disappear. So negative times negative is positive, and there's just 3x squared. And negative times positive is negative, and there's a 3x. Now all I'm looking to do is find my like terms. I've got those two. I tested in advance and the highlighter doesn't show up on this background color, so I'm going to circle them. The two in purple, pink, whatever color that is, have x squared terms, so 8 plus 3 is 11. There's 11 x squareds. And the ones circled in green, negative 3x minus 3x. Negative 3x minus 3x is negative 6x. And this is the simplified version of what we started with at the top here. So here's a few questions, I think 6 questions, just to check if you know all of these different types of polynomial problems.